YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be giving you a complete review of fractions. More specifically, I'm going to be covering the following topics in today's video. First, I'm going to start by discussing some very basic fraction terminology, and after that, I'm going to show you how to reduce fractions. Before we work on adding and subtracting fractions, we're going to talk about finding common denominators and writing equivalent fractions. After we do that, we're going to move on to adding and subtracting fractions as well as multiplying and dividing fractions. Next to last, we're going to talk about mixed numbers and we're going to perform some operations involving mixed numbers. And then finally, I'm going to show you how to convert fractions to decimals as well as percentages. So before we get started, I want to mention a few other things. Of course, I want to point out that for each of these topics, there will be 5 to 10 practice questions. In order to get the most from this video, you'll want to pause the video after I read a practice question, attempt to work out the question on your own, and then resume playing the video to check your solution. Similarly, I want to mention that in the description of this video, I'm going to have timestamps that will be associated with each of these topics. So if for whatever reason you want to jump ahead to a certain part of this video, you can go ahead and do so by clicking on those timestamps. So with all that being said, let's go ahead and get started with our review of fraction terminology. So throughout the rest of this video, I'm going to use the following terms, and for that reason, I feel as if you need to be familiar with them. And those terms are right here: numerator, denominator, equivalent fractions, and improper fraction. Let's start by talking about what numerators and denominators are. As you can see, a numerator is the number above the division bar in a fraction, whereas a denominator is the number below the division bar in a fraction. So for instance, if I gave you the fraction 2/5, you should be able to tell me that 2 is our numerator and 5 is our denominator. All right, let's talk about improper fractions since those are pretty easy to understand. In an improper fraction, the numerator is larger than the denominator. So for instance, we have the fraction 7/4. Of course, 7 is bigger than 4, and for that reason, we would refer to the fraction 7/4 as an improper fraction. Let's take a look at another example of an improper fraction. Let's say we had the fraction 9/2. Since 9, our numerator, is bigger than 2, our denominator, we would refer to 9/2 as an improper fraction. Finally, let's briefly talk about equivalent fractions. As you can imagine, that means that two fractions are simply equal to each other. In the example they gave there is 1/2 is equal to 3/6. How do you know that 3/6 and 1/2 are equal? Well, as we'll talk about in just a few seconds here, you can reduce 3/6 to be 1/2. As a matter of fact, let's do that quickly off to the side. Um, when you reduce fractions, you try to divide both the numerator and denominator by the same term. So for instance, you should know that 3 and 6 can be divided by 3. 3 divided by 3, of course, is 1. 6 divided by 3 is 2. So by reducing 3/6 by a factor of 3, we know that it is equivalent to the fraction 1/2. As a matter of fact, that's the very next topic in this video. So let's go ahead and take a look at it. All right, so now let's work on reducing fractions. And of course, that's the same thing as placing fractions in simplest terms. And as you can see, we have 6 practice problems. So after I do the first 2, you may want to pause the video and attempt to do the remaining 4 on your own. The key to reducing fractions is this: you want to find a number that goes into both the numerator and denominator so that you can reduce it. And let's take a look at 9/12 here. What number goes into both 9 as well as 12? Well, you should realize that 3 goes into both 9 and 12. Therefore, we can divide both 9 and 12 by 3. 9 divided by 3, of course, is 3. 12 divided by 3 is 4. All right, so The equivalent fraction of 9/12 is 3 over 4. All right, let's move on to the next one now. We want to reduce the fraction 12 over 28. So in light of that, we're looking for a number that goes evenly both into 12 and 28. This one's a little bit more challenging, so it may take a few minutes to figure that out. Well, you should know that 4 goes into both 12 and 28. In other words, 12 divided by 4 is 3, 28 divided by 4 is 7. And since we can't reduce this any further, we know the equivalent fraction of 12 over 28 is 3 over 7. All right, let's move on to number 3 now. Again, to reduce 15 over 40, we're looking for a number that goes into 15 as well as 40. And this one should be pretty easy. You should realize that both 15 and 40 can be divided by 5. 15 divided by 5, of course, is 3. 40 divided by 5 is 8. We can't reduce this any further since we can't find a number that goes into both 3 and 8. So the equivalent fraction of 15 over 40 is 3 over 8. That is in simplest terms. All right. Let's take a look at number 4 now. Again, we're trying to reduce the fraction 21 over 36. In other words, we're trying to find a number that goes both into our numerator and denominator. This one might take a while to figure out, but you should realize that 21 and 36 can be divided by 3. 21 divided by 3 is 7, and 36 divided by 3, well, 3 goes into 3 one time, 3 goes into 6 two times. So the equivalent fraction of 21 over 36 is 7 over 12. And since 7 and 12 don't have a common number that we can reduce them by, we know that this is in simplest terms. You should be getting the hang of this by now. There's really nothing too difficult about reducing fractions. But now let's reduce the fraction 8 over 20. Again, we're looking for a number that goes into both 8 and 20. This one should be pretty easy as well. You should know that 4 goes into 8 as well as 20. As a matter of fact, 8 divided by 4 is 2, and 20 divided by 4 is going to be 5. 2 and 5 don't have a common factor, so we know that is in simplest terms. And therefore, we know the equivalent fraction of 8 over 20 is simply 2/5. All right, let's do one more to drive the point home. We're looking to reduce the fraction 6 over 14. And in other words, we're looking for a number that goes into both 6 and 14 evenly. In this case, it's going to be 2, so we're going to divide 6 as well as 14 by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. We can't reduce this any further, so we know the equivalent fraction of 6 over 14 is 3 over 7. All right, so now that we've discussed reducing fractions, let's talk about finding common denominators and writing equivalent fractions. As you can see in this first example, we have to find a common denominator between 7/8 and 2/4. And once we do that, we have to write equivalent fractions with the common denominator. All right, so we're working with two fractions, 7/8 and 2/4. Our first task is to find a common denominator. Well, you should realize that a common denominator is referring to the denominator, so we're only looking at 8 and 4 in this case because those are the denominators of our fractions. And one strategy people use to find common denominators is this. They'll take their denominators. In this case, we have a denominator of 4 and a denominator of 8. And they'll list out multiples until they find the one that they have in common. So what are the multiples of 4? That's going to be 4, 8, 12, 16, 20, 24, and so on and so forth. What are the multiples of 8? Well, that's going to be 8, 16, 24, 32. What multiple do they have in common? Well, as you can see, 8 appears both here and here. Therefore, the common denominator between 7/8 and 2/4 is going to be 8. All right, so now that we've identified a common denominator, let's go ahead and write equivalent fractions with that common denominator. So in other words, as needed, we're going to rewrite one or both of these fractions with a denominator of 8, which is our common denominator. Well, since we already have a denominator of 8 and 7/8, we're just going to copy that one down as is. There's nothing to do there. But to rewrite 2/4 as an equivalent fraction with a common denominator of 8, we're going to take 4 and we're going to multiply it by 2. Again, 4 times 2 is 8. And then we're also going to do that to its numerator. 2 times 2 is 4. All right, so the equivalent fraction of 2/4 with a common denominator of 8 is 4/8. And you might be asking yourself, why am I doing that? Why am I rewriting these fractions over the common denominator? Well, as you might expect, in order to add and subtract fractions, that's exactly what we're going to be doing. So we might as well see it now. All right, so in this second example, we're trying to find a common denominator between 1/5 and 2/6. Once we do that, we're going to rewrite both of those fractions such that they are equivalent fractions with the same common denominator. All right, so let's go ahead and work on identifying a common denominator between 1/5 and 2/6. As I just mentioned, one strategy you can use is to take your denominators, which are 5 and 6 in this case, and list out all of their multiples until you find the one they have in common. Well, what are factors of 5? We have 5, 10, 15, 20, 25, 30, 35, and so on and so forth. What are the multiples of 6? We have 6, 12, 18, 24, 30, 36. Which multiple do they have in common? Clearly, they have the multiple 30 in common. So we know the common denominator between 1/5 and 2/6 is going to be 30. And now let's rewrite both of these fractions such that they have that common denominator. All right. To write 5 as 30, we would have to multiply 5 by 6. And we're also going to do that to its numerator. 5 times 6 is 30. 1 times 6 is 6. So the equivalent fraction of 1/5 is 6/30. Let's go ahead and do the same thing with 2/6 to write 2/6 with a common denominator of 30. We're going to multiply it by 5. 6 times 5 is 30, of course. And we're going to do that to its numerator as well. 2 times 5 is 10. So the equivalent fraction of 2/6 with a denominator of 30 is 10/30. All right, so that is that one. All right, so for this third example, we're going to find a common denominator between 3/16 and 1/2. And then, as needed, we'll rewrite them as equivalent fractions with that same common denominator. So we're working with the fractions 3/16 and 1/2. As I mentioned, one strategy you can use to find the common denominator is to list out the multiples of your denominator. So in this case, we have denominators of 2 and 16. What are the multiples of 2? Well, that's 2, 4, 6, 8, 10, 12, 14, 16, 18. What are the multiples of 16? Well, that's 16, 32. And that's all we have to list because as you can see here and here, they have the multiple 16 in common. Therefore, we know our common denominator is 16. All right, so as needed, let's rewrite these fractions with a common denominator of 16. Well, as it happens, 3/16 already has a denominator of 16, so we'll just copy that one down as is. To write 2 as 16, we would multiply it by 8. 2 times 8 is 16, and we also have to do that to its numerator. 1 times 8 is 8. So the equivalent fraction of 1/2 with a denominator of 16 is 8/16. All right, let's take a look at two more examples. So for number four, we're trying to find a common denominator between 1/9 and 1/2. And then once we do that, we'll rewrite either one or both of these fractions over that common denominator. And of course, one strategy you could use to find the common denominator is to list out multiples of your denominators. So in this case, we have denominators of 2 as well as 9. What are multiples of 2? Well, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That should be enough. What are multiples of 9? We have 9, 18, 27, and that should be enough. As you can see, we have a common multiple of 18 there and there. So our common denominator, in other words, is going to be 18. Now let's rewrite both of these fractions as equivalent fractions with a denominator of 18. Well, to write 9 as 18, I would have to multiply it by 2, and I'm also going to have to do that to its numerator. 9 times 2 is 18. 2 times 1 is 2. So the equivalent of 1/9 is 2 over 18. All right, let's go ahead and write 1/2 with a common denominator of 18. To write 2 as 18, we would have to multiply it by 9. And of course, we'll also have to do that to its numerator. 2 times 9 is 18. 1 times 9 is 9. All right, so we just went ahead and rewrote both of those fractions such that they have a common denominator of 18. All right, so for this fifth and final example for this topic, we're trying to find a common denominator between 12 over 30 and 3 over 6. And then, of course, we'll rewrite both those fractions such that they have a common denominator. So we're working with the fraction 12 over 30 and 3 over 6. As I said, one strategy you can use to find a common denominator is to list out the multiples of your denominators. So let's list out the multiples of 6 as well as 30. The multiples of 6, of course, are 6, 12, 18, 24, 30, 36, and so on and so forth. Multiples of 30 are 30, 60, 90, 120, and so on and so forth. And as you can see, they have the multiple of 30 in common. In other words, our common denominator is 30. So let's rewrite both these fractions with that common denominator of 30. Um, so as you can see, 12 over 30 is already over our common denominator. So we'll just copy that one down as is. To express 3 over 6 with a denominator of 30, we would have to multiply 6 by 5, and we're also going to have to do that to its numerator. 6 times 5 is 30. 3 times 5 is 15. All right, so we are done with that one. All right, so now that we've talked about finding common denominators as well as how to reduce fractions, let's talk about how to add and subtract fractions. And let me just stress this. In order to add and subtract fractions, the fractions have to have a common denominator. All right. So with that said, let's take a look at this first example. We're trying to add the fractions 3 over 4 plus 2 over 5. As it stands, those do not have a common denominator. So our next step is to rewrite either one or both of these fractions such that they do have a common denominator. And once we do that, we'll be able to add them together very quickly. And if you still need to see it, we can go ahead and list out the multiples of 4 and 5 in order to find our common denominator. Well, multiples of 4 are 4, 8, 12, 16, 20, 24, 28, and so on and so forth. Multiples of 5 are 5, 10, 15, 20, 25, 30. And as you can see, they have the multiple 20 in common. So in order to add these two fractions, we're going to rewrite both of them such that they are over the common denominator of 20. In order to write 4 as 20, we would multiply that by 5, and we also have to do that to its numerator. 5 times 4, of course, is 20. 5 times 3 is 15. Again, 15 over 20 is the equivalent fraction of 3 over 4. To write 5 as 20, we would multiply it by 4, and we're also going to do that to its numerator. 5 times 4 is 20. 2 times 4 is 8. All right, so now that we've rewritten these fractions such that they have a common denominator of 20, we can simply add them together like this. Again, the denominator is not going to change, but we'll do 15 plus 8. All right, so let's go ahead and add those. If you need to, you can do 15 plus 8 off to the side, although you should be able to do that mentally. 5 plus 8, that's 8, 9, 10, 11, 12, 13. Carry a 1. 1 plus 1 is 2. So this is 23 over 20. In other words, 3/4 plus 2/5 is 23 over 20. And what do you notice about 23 over 20? Well, our numerator is bigger than our denominator, which means that it is an improper fraction. As you'll see in just a few minutes, we can't leave this as an improper fraction. We would have to express this as a mixed number. And I'm going to show you how to do that in just a few minutes here. All right, so for number 2, you can see that we are adding 1/10 and 2/10 together. In order to add and subtract fractions, they have to have a common or the same denominators. In this case, we have a denominator of 10 and a denominator of 10. Therefore, we don't have to rewrite these fractions because they have the same denominator, which means we're simply going to add them real quick. This is going to be 1 plus 2. 1 plus 2 is 3. All right, so 1/10 plus 2/10 is simply 3/10. And we cannot reduce that. So for number 3, we're trying to add 1/7 and 3 over 2. Well, in order to add and subtract fractions, they have to have a common or the same denominator. Here we have a denominator of 7. Here we have a denominator of 2. So we can't just add these together right now. Instead, we have to rewrite one or both of these fractions such that they are over a common denominator, and then we can add them. And of course, one strategy you can use to find that common denominator is to list out the multiples of your denominators. What are the multiples of 2? Well, that's 2, 4, 6, 8, 10, 12, 14, 16, 18. What are the multiples of 7? That's going to be 7, 14, 21, 28. Do they have a multiple in common? They do, notably 14. So we know 14 is going to be our common denominator. In other words, that's going to prompt us to write both of these fractions such that they have a common denominator of 14, which is going to enable us to add them. To write 7 as 14, we multiply by 2. We're also going to do that to its numerator. 7 times 2 is 14. 2 times 1 is 2. To write 2 as 14, we would have to multiply it by 7 since 2 times 7 is 14. We're also going to have to do that to its numerator. 3 times 7 is 21. Now that these fractions have a common denominator, we can go ahead and add them. Again, our denominator is going to stay the same, but we are going to add our numerators. In this case, we have 2 plus 21, which is going to be 23 over 14. All right, what do we notice about our answer? It is an improper fraction, meaning that our numerator, 23, is bigger than our denominator. And of course, as I just mentioned, we're going to learn how to convert improper fractions to mixed numbers in just a few minutes. All right, so now we have a subtraction problem, notably 5/8 minus 1 over 7. In order to add and subtract fractions, they have to have a common denominator. In this case, we have a denominator of 8 and 7, which are not the same. So we're going to have to rewrite either one or both of these fractions such that they do have a common denominator. And as we've discussed already, we can simply list out the multiples of our denominators to do so. We have a denominator of 7, so we'll list out the multiples of 7, and a denominator of 8. So we'll list out the multiples of 8 until we find the one that they have in common. Multiples of 7: 7, 14, 21, 28, 35, 42, 49, 56. All right, let's list out the multiples of 8 now. That's going to be 8, 16, 24, 32, 40, 48, and 56. So as you can see, both 8 and 7 have a common multiple of 56. In other words, that's going to be our common denominator. In other words, we're going to rewrite both 5/8 as well as 1/7 with a common denominator of 56. To write 8 as 56, we would have to multiply it by 7. And of course, we're also going to do that to its numerator. 7 times 8 is 56. 7 times 5 is 35. To write 7 as 56, we would have to multiply it by 8. And we're also going to do that to its numerator. 7 times 8 is 56. 1 times 8 is 8. So now that we have rewritten both of our fractions with a common denominator, we can go ahead and perform this subtraction. Again, our denominator is not going to change, but we have 35 minus 8. And you should be able to do that in your head. That said, if you can't, you could always do it off to the side like this: 35 minus 8. Can't do 5 minus 8, so we're going to have to borrow. This is going to become 2. This is going to become 15. 15 minus 8 is going to be 7. 2 minus nothing is 2. So this is 27 over 56. All right, so that is that one. All right, so let's take a look at number 5 now. We have 7 minus 1/4. 7 minus 1/4. And some of you are probably saying, well, what am I going to do now? I don't know how to subtract a fraction from a whole number. Well, let me just point this out. You can write all whole numbers as fractions by placing them over 1. Let me repeat that. You can rewrite all whole numbers as fractions by placing them over 1. So the equivalent fraction of 7 is 7 over 1. What is 7 divided by 1? 7 divided by 1 is 7. Let's say I asked you to write 5 as a fraction. You'd simply place it over 1. What is 5 divided by 1? It's 5. How do you write 100 as a fraction? You simply place it over 1. All right, so let's start by rewriting 7 as a fraction by placing it over 1. Again, in order to add and subtract fractions, they have to have a common denominator. In this case, our denominators are 1 and 4. So if it's helpful, you can list out multiples of 1 and 4 until you find the one they have in common. What are multiples of 1? Well, that's 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. What are multiples of 4? That's going to be 4, 8, 12, 16, and so on and so forth. What multiple do they have in common? Of course, they have 4 in common. So that's going to be our common denominator. And now let's rewrite either one or both of these as fractions with a denominator of 4 so that we can go ahead and subtract them. To write 1 as 4, we would multiply it by 4. And we're also going to do that to its numerator. Uh, 4 times 1 is 4. 7 times 4 is 28. 1/4 already has a denominator of 4, so we'll just copy it down as is. So this becomes 28 over 4 minus 1 over 4. Again, our denominator is not going to change when we add and subtract. So this becomes 28 minus 1, which is 27 over 4. Of course, this is an improper fraction, so you can convert that to mixed number. I'm going to show you how to do that momentarily. But that is that one. For number 6, we have the same thing. We're trying to add the whole number 1 to 1/5. Of course, you should know that 1 plus 1/5 is going to be 1 and 1/5. That said, I want to drive home this point again. You can write all whole numbers as fractions by placing them over 1. So you can write the whole number as a fraction by placing it over 1. Again, 1 is the same thing as 1 over 1. 1 divided by 1 is 1. So in other words, this is 1 over 1 plus 1 over 5. And if it's helpful, you can list out multiples of our denominators in order to find a common denominator. Again, we have a denominator of 1 and a denominator of 5. Multiples of 1, that's 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. Multiples of 5, that's 5, 10, 15, 20. Do they have one in common? Of course, they have the multiple of 5 in common, so we know that's going to be our common denominator. In other words, in order to add these two fractions, we're going to express them with a denominator of 5. To write 1 as 5, we would multiply it by 5. We're also going to do that to its numerator. 1 times 5 is 5. 1 times 5 is 5. So the equivalent fraction of 1 is 5 over 5. Since 1/5 already has a denominator of 5, we're just going to copy it down as is. Now that we have a common denominator, we can go ahead and add these two fractions together. Again, our denominator is not going to change, so this becomes 5 plus 1. 5 plus 1 is 6, so this is 6 over 5. Again, that's an improper fraction, and of course, we can express improper fractions as mixed numbers, which we'll do in just a few minutes here. Let's take a look at number 7 now. We have 2/3 minus 1/6. In order to add and subtract fractions, the fractions have to have a common or the same denominator. In this case, we have a denominator of 3 and a denominator of 6. So we're going to have to rewrite either one or both of these fractions such that they have a common denominator. In order to find that common denominator, we can take our denominators, notably 6 and 3 in this case, and list out multiples of each of those until we find the one they have in common. What are the multiples of 3? That's 3, 6, 9, 12, 15, and so on and so forth. What are the multiples of 6? Well, that's 6, 12, 18, and so on and so forth. Which one do they have in common? They have 6 in common. So our common denominator, in other words, is 6. So in order to subtract these fractions, we're going to express them both with a denominator of 6. To write 3 as 6, we would multiply it by 2. We're also going to do that to its numerator. 2 times 3 is 6. 2 times 2 is 4. Since 1/6 already has a denominator of 6, we'll just bring it down as is. This becomes 4 over 6 minus 1 over 6. Again, our denominator is not going to change, so this becomes 4 minus 1. 4 minus 1 is 3, so this is 3 over 6. Can we reduce 3 over 6? In other words, is there a number that goes into both 3 and 6 evenly? There is. We know that 3 and 6 can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So 2/3 minus 1/6 is 1/2. All right, so that is that one. All right, let's do one more. We have 5 over 6 minus 2 over 6, and this one's nice and easy. In order to add and subtract fractions, they have to have the same or a common denominator. In this case, we have a common denominator of 6 for both of these. So we're simply going to keep our denominator the same and do 5 minus 2. 5 minus 2 is 3. This is 3 over 6, and we should know that that reduces to 1/2. So that is that one. All right. So now that we've talked about adding and subtracting fractions, which in all honesty is one of the more difficult topics in this video, let's talk about multiplying and dividing fractions. Thankfully, multiplying and dividing fractions is very, very straightforward. When you multiply two fractions, you just multiply straight across and reduce as needed. So let's take a look at our first example. We have 1/2 times 5/4. Again, when you multiply fractions, you just multiply straight across and then reduce. So what do I mean by multiply straight across? This becomes 1 times 5, and then 2 times 4. 1 times 5, of course, is just 5. 2 times 4 is 8. And just like that, we did number 1. As you just saw, we just multiplied straight across. We did not have to find a common denominator, and we did not have to write any of our fractions as equivalent fractions with that common denominator. Multiplying and dividing fractions is super easy. That said, let's take a look at a few more examples here. For this second problem, we have 1/4 times 2/5. Let me move up a little bit. Again, in order to multiply fractions, you just multiply straight across and then reduce as needed. What do I mean by multiply straight across? We do 1 times 2, like that. And then we do 4 times 5. 1 times 2 is 2. 4 times 5 is 20. As I said, we reduce as needed. Is there a number that goes into both 2 and 20 evenly? Well, you should see that both 2 and 20 are divisible by 2. So we're going to reduce 2 and 20 by a factor of 2. 2 divided by 2 is 1. 20 divided by 2 is 10. So 1/4 times 2/5 is 1/10. Again, multiplying fractions is easy and straightforward. Let's move on to number 3 now. We have 1/3 times 5/10. Multiplying those two fractions together, just going to multiply straight across. That's all there is to it. So this becomes 1 times 5/3 times 10. 1 times 5 is 5. 3 times 10 is 30. Can we reduce the fraction 5/30? Yes, we can. 5 goes into both 5 and 30. 5 divided by 5 is 1. 30 divided by 5 is 6. All right, so 1/3 times 5/10 is 1/6. All right, let's do one more. And as you can see for number 4, we have 3/11 times 3/4. When we multiply fractions, we just multiply straight across. There's nothing more to it than that. So this becomes 3 times 3/11 times 4. 3 times 3 is 9. 11 times 4 is 44. We can't reduce this, so our answer is 9/44. And that is that one. Again, multiplying fractions is straightforward. You should be able to do it in your sleep. All right, so if you can multiply fractions, then you should be able to divide fractions as well. It's just as easy. There's just one additional thing you have to remember. That is keep, change, flip. Okay? This K refers to keep. It means keep the first fraction the same. This change says change from division to multiplication. And this F means flip. It means take your second fraction and flip it. So let's see what that looks like in practice. So right here we have 2/5 divided by 1/3. Remember, keep, change, flip. Keep the first fraction the same. So we're going to keep 2/5 as is. That's our keep. We're going to change from division to multiplication. So that's our change. And then flip refers to this second fraction. We're going to flip it. So instead of being 1/3, it's going to be 3/1. Now we simply have a problem involving the multiplication of two fractions. And of course, when you multiply two fractions, you just multiply straight across. This becomes 2 times 3/5 times 1. 2 times 3, of course, is 6. 5 times 1 is 5. All right. That is an improper fraction, so you can express it as a mixed number. We're going to talk about that in just a few minutes. But that said, 2/5 divided by 1/3 is 6/5. Let's go ahead and take a look at another example now. We have 4/13 divided by 1/4. Again, remember, when we divide fractions, we're going to do keep, change, flip. We're going to keep this first fraction the same, so we're going to keep 4/13 as is. We're going to change from division to multiplication, and then we're going to flip our second fraction, so instead of being 1/4, it's going to be 4/1. Now we're just multiplying two fractions together. And again, to multiply two fractions, you simply multiply straight across. This becomes 4 times 4 over 13 times 1. 4 times 4 is 16. 13 times 1 is 13. All right, so that is that one. Again, this is an improper fraction, so you could express it as a mixed number. We're going to take a look at that as our next topic. All right, so for number 7, you can see that we have 1/2 divided by 1/2. Some of you already know the answer to this one. That said, let's use our algorithm to figure this one out. We have the algorithm keep, change, flip that we use when we're dividing fractions. Uh, K refers to keep. That means keep the first fraction the same, so we'll keep 1/2 as is. C refers to change. We change from a division to multiplication. F refers to flip, which means we're going to take this 1/2 and flip it. So in other words, it's going to be 2 over 1. Now we just have a multiplication problem here. When you multiply fractions, you just multiply straight across. So this becomes 1 times 2 over 2 times 1. 1 times 2 is 2. 2 times 1 is 2. 2 over 2 is just 1. So 1/2 divided by 1/2 is simply 1. All right, let's take a look at number 8 now. You can see that we have 8 over 15 over 2 over 5. Well, this big uh, fraction bar right here actually means to divide. So you would read this as 8 over 15 divided by 2 over 5. And since we're dividing two fractions, we're going to follow the algorithm keep, change, flip. All right, so keep refers to this top fraction. Keep it the same, so it's going to be 8 over 15. Change refers to this division bar. We're going to change it from division to multiplication. And flip refers to the second fraction, so instead of being 2 over 5, we're going to flip it to be 5 over 2. All right, now we're just multiplying two fractions, which means we're just going to multiply straight across. This becomes 8 times 5 over 15 times 2. 8 times 5 is 40. 15 times 2 is 30. We can reduce this by crossing out these zeros. So this reduces to 4 over 3. So 8 over 15 divided by 2 over 5 is 4 over 3. Of course, that is an improper fraction, so we can express that as a mixed number. As a matter of fact, we're now going to talk about mixed numbers. All right, so now that we've talked about reducing fractions, finding common denominators, equivalent fractions, adding and subtracting fractions, and multiplying and dividing fractions, let's talk about improper fractions and mixed numbers. More specifically, let's talk about how to convert improper fractions to mixed numbers. So, we have the improper fraction 7 over 4, and we want to write that as a mixed number. Well, how do we do that? Well, you can read all fractions as long division. In other words, I can read 7 over 4 as 7 divided by 4 like this. So 7 division bracket divided by 4. And by performing this long division right here, I'll be able to convert this improper fraction of 7 over 4 to a mixed number very quickly. We start this long division by asking ourselves, how many times does 4 go into 7 without going over? That's one time, since 4 times 1 is 4. 7 minus 4 is 3. All right, so at this point, we have enough to write 7 over 4 as a mixed number. This number right here is going to be our whole number. Our remainder of 3 is going to be our numerator of our fraction. And this divisor of 4 is going to be our denominator. So 7 over 4 as a mixed number is 1 3/4. And we use some simple long division to figure that out. All right, let's do the same thing with 12 over 5. We want to express the improper fraction 12 over 5. Let me move over a little bit. We want to express the improper fraction 12 over 5 as a mixed number. Well, that's actually pretty easy to do. We could read this as 12 divided by 5. And by performing this long division, we'll be able to write 12 over 5 as a mixed number. Let's start this long division. How many times does 5 go into 1 without going over? It doesn't. How many times does 5 go into 12 without going over? That would be 2 times. 5 times 2, of course, is 10. 12 minus 10 is 2. And now we have enough to write our mixed number. This 2, of course, is going to be our whole number. This remainder of 2 is going to be our numerator, and this divisor of 5 is going to be our denominator. So 12 over 5 is the same thing as 2 and 2 fifths. All right, so now we've seen how to express improper fractions as mixed numbers. Let's go ahead and express mixed numbers as improper fractions. So we want to write 5 and 2 sevenths as an improper fraction. So we want to express 5 and 2 sevenths as an improper fraction. This is actually pretty easy to do. Your denominator of 7 is not going to change. So go ahead and write 7 as the denominator of your improper fraction. Then we're going to take these two and multiply them. 5 times 7 is 35. And then we add our numerator. So 5 times 7 is 35, plus 2 is 35, 36, 37. So this is 37 over 7. All right, let's do one more. We want to express the mixed number 1 and 1/5 as an improper fraction. Our denominator is not going to change, so we're going to go ahead and write that in the denominator of our improper fraction. Then we do 1 times 5. We multiply these two together. 1 times 5 is 5, and then we just add our numerator. 1 times 5 is 5, plus 1 is going to be 6. So 1 and 1/5 as an improper fraction is 6 over 5. All right, so now that we know how to convert improper fractions to mixed numbers and mixed numbers to improper fractions, let's go back through our exercises, and as needed, we'll convert those improper fractions to mixed numbers. As you can see for number 8 right here, our answer was 4 over 3. And in case you can't leave it like that, we're going to convert the improper fraction 4 over 3 to mixed number. Again, you read this as long division. So we can read this as 4 divided by 3. And we ask ourselves, how many times does 3 go into 4 without going over? That's 1 time, since 1 times 3 is 3. 4 minus 3 is 1. And we have enough to express this as a mixed number. This 1 is going to be our whole number. This remainder of 1 is going to be our numerator. And this 3 is going to be our denominator. So this is 1 and 1/3. All right, so that is that one. Right here, we had the improper fraction of 16 over 13, and we want to express that as a mixed number. So we do that by reading this as long division. So I'm going to read this as 16 divided by 13. We perform this long division by asking ourselves, how many times does 13 go into 1? It doesn't. How many times does 13 go into 16 without going over? That's going to be 1 time. 13 times 1 is 13. 16 minus 13 is 3. All right, so we have enough to express this as a mixed number. This 1, of course, is going to be our whole number. This remainder of 3 is going to be our numerator, and this divisor of 13 is going to be our denominator. All right, so 16 over 13 is the same as 1 and 3/13. Here we had 6 over 5. Let's go ahead and express that as a mixed number as well. Again, we read this as 6 divided by 5. 6, we start this long division by asking ourselves, how many times does 5 go into 6 without going over? That's 1 time. 1 times 5 is 5. 6 minus 5 is 1. So we have enough to write this mixed number. This 1 is going to be our whole number. This remainder of 1 is going to be our numerator. And this 5 is going to be our denominator. So 6 over 5 is the same thing as 1 and 1/5. All right, so that's enough practice doing that. You should see that you can always express improper fractions as mixed numbers by performing some simple long division. All right, so if you wanted to, you could go through all the other ones and rewrite those as needed. That said, let's get back to our discussion of mixed numbers, and more specifically, let's work on performing some operations involving mixed numbers. All right, so let's go ahead and talk about how to add, subtract, multiply, and divide mixed numbers. And let me just say this, you already have all the skills to do this. That said, for each of these problems, you're going to have to use almost every single one of them at once. So for number 5, we're trying to add 1 and 1/5 and 2 and 1/3. That is, we're trying to add two mixed numbers. Well, I've only talked about adding and subtracting fractions. More specifically, I've always mentioned that to add and subtract fractions, they have to have the same or a common denominator. Well, the first thing we're going to have to do in this case is rewrite both of these as improper fractions. All right, so let's work on doing that first. Let's write 1 and 1/5 as an improper fraction. Again, our denominator is not going to change. And then we're going to take 1, we're going to multiply it by 5. 1 times 5 is 5. And then we're going to add this numerator of 1. So 1 times 5 is 5, plus 1 is 6. All right, so we just express 1 and 1/5 as an improper fraction. Let's go ahead and do that for 2 and 1/3 now. Again, our denominator of 3 is not going to change. Then we do 2 times 3, which is 6, plus 1, which is 7. All right, so now we're adding two fractions, and most people know how to do this by now. Again, to add two fractions, we have to have a common denominator. That is, our denominators have to be the same. In this case, we have a denominator of 5 and 3, which are not the same. One strategy you can use to find a common denominator is to list out the multiples of your denominator. So we have a denominator of 5 and 3. What are the multiples of those? That's 5, 10, 15, 20, 25. What are the multiples of 3? 3, 6, 9, 12, 15, and so on and so forth. Do we see the common multiple between those two? It's right here. It's 15. So in other words, our common denominator is going to be 15. And that means we're going to rewrite either one or both of these fractions as needed with a common denominator of 15. To write 5 as 15, you would multiply it by 3. We're also going to do that to its numerator. 3 times 5 is 15. 3 times 6 is 18. To write 3 as 15, we would multiply it by 5, and we're also going to do that to its numerator. 3 times 5 is 15. 7 times 5 is 35. So this becomes 18 plus 35 over 15. Of course, if you can't do that math mentally, you can always do it off to the side. You have 35 plus 18. 8 plus 5, that's 8, 9, 10, 11, 12, 13. Drop down to 3, carry a 1. 3 plus 1 is 4, plus 1 is 5. So this becomes 53 over 15. Well, we can't leave this as an improper fraction. We want our answer to be a mixed number, and we already know how to express improper fractions as mixed numbers. So let's go ahead and do that. To express an improper fraction as a mixed number, you simply perform the long division that the fraction tells you to do. This says 53 divided by 15. All right, so let's do this long division. First, we ask ourselves, how many times does 15 go into 5 without going over? It doesn't. How many times does 15 go into 53 without going over? Well, that's going to be 15, 30, 45. So that's going to be 3 times. 15 times 3 is 45. Um, 3 minus 5 we can't do, so we're going to have to borrow. This becomes 4. This becomes 13. 13 minus 5 is 8. 4 minus 4 is 0. And just like that, we have enough to express this improper fraction as a mixed number. This 3 is going to be our whole number. This 8 is going to be our numerator. And this 15 is going to be our denominator. All right, so 1 and 1/5 plus 2 and 1/3 is 3 and 8 over 15. Number 6 says 5 and 1/2 plus 2/10. So we have 5 and 1/2. And to that, we're adding 2/10. Again, we want to write these such that we're adding two fractions together. So that means we're going to have to take this 5 and 1/2 and express it as an improper fraction. We know our denominator is not going to change, so that's going to be a 2. Then we do 5 times 2, which is 10, plus 1, which is 11. So that's 11/2 plus 2/10. Since we're adding two fractions, we have to first ensure that they have the same or a common denominator. In this case, we have a denominator of 2 and a denominator of 10. Those are not the same. So, one strategy some people use to find a common denominator is to list out the multiples of their denominators. So, we're going to list out the multiples of 2 as well as the multiples of 10. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on. Multiples of 10, 10, 20, 30, 40. Do they have one in common? They do. They have that 10 in common. So we're going to rewrite these with a common denominator of 10. Let's go ahead and get that set up real quick. To write 2 as 10, we would multiply it by 5. We're also going to do that to its numerator. 5 times 2 is 10. 5 times 11 is 55. This one already has a denominator of 10, so we'll just copy it down as is. So you can see that this becomes 55/10 plus 2/10, which becomes 55 plus 2/10. 55 plus 2 is 55, 56, 57. This is 57/10. All right, so we have an improper fraction, which we need to convert to mixed number now. And to convert an improper fraction to mixed number, you simply perform that long division. This tells us to do 57 divided by 10. And we ask ourselves, how many times does 10 go into 5 without going over? It doesn't. So now we move on and ask ourselves, how many times does 10 go into 57 without going over? Well, that's going to be 5 times, given that 5 times 10 is 50. 57 minus 7 is 7. We have enough to write this as a mixed number now. This 5 is our whole number. This remainder of 7 is our numerator. And this 10 is our denominator. All right, so 5 and 1/2 plus 2/10 is 5 and 7/10. All right, so for number 7, we have 3 and 4/10 minus 1 and 1/2. So again, we have 3 and 4/10 minus 1 and 1/2. I've only shown you how to add and subtract fractions. So the first thing we have to do in this case is convert these mixed numbers to be improper fractions. And that's pretty easy to do. Our denominator of 10 is not going to change here, but then we do 3 times 10, which is 30 plus 4, which is 34, minus, again, for this one, our denominator of 2 is not going to change. All right, to find a numerator, we go 1 times 2 plus 1. So 1 times 2 is 2, plus 1 is 3. So now we're subtracting two fractions. In order to add and subtract fractions, they have to have a common or the same denominator. In this case, we have a denominator of 10 and a denominator of 2. So we're going to have to rewrite either one or both of these such that they have the same denominator. One strategy people use to find the common denominator is to list out multiples of their denominators. So we have a denominator of 2 and a denominator of 10 in this case. What are the multiples of 2? That's 2, 4, 6, 8, 10, 12, 14, 16. What are the multiples of 10? That's 10, 20, 30, 40. What multiple do they have in common? As you can see, that is 10. All right, so we're going to rewrite either one of the or both of these such that they have a common denominator of 10. This one already has a denominator of 10, so we'll just bring it down as is. To write 2 as 10, we would multiply it by 5. We're also going to have to do that to its numerator. 2 times 5 is 10. 3 times 5 is 15. Now we can go ahead and subtract these fractions. This becomes 34 minus 15 over 10. If you can't do that mentally, you could always do it off to the side like this. 34 minus 15. 4 minus 5 we can't do, so we have to borrow. This becomes 2. This becomes 14. 14 minus 5 is going to be 9. 2 minus 1 is 1. So this is 19 over 10. This is an improper fraction, which means we can write it as a mixed number. How do we do that? Well, we perform this long division. This says 19 divided by 10. How many times does 10 go into 1 without going over? It doesn't. How many times does 10 go into 19 without going over? That's one time. 1 times 10 is 10. 19 minus 10 is 9. We have enough to write our mixed number. This 1 is going to be our whole number. This 9 is going to be our numerator. And this 10 is going to be our denominator. All right, so the answer to this one is 1 and 9 tenths. In other words, 3 and 4 tenths minus 1 and 1 half is 1 and 9 tenths. All right, so for number 8, we're multiplying 1 and 1/8 by 8. So again, just going to copy that down real quick. We have 1 and 1/8 times 8. In this video, I've only talked about multiplying fractions. And in this case, we're multiplying a mixed number by a whole number. So the first thing we want to do is rewrite both of those as fractions, more specifically as improper fractions. So let's rewrite 1 and 1/8 as an improper fraction. We know our denominator is going to be 8. To find its numerator, we do 1 times 8 plus 1. 1 times 8 is 8, plus 1 is 9. And of course, to write 8 as a fraction, we simply place it over 1. Now we're ready to multiply fractions. We just multiply straight across. So this becomes 9 times 8 over 8 times 1. This one should be pretty easy to see, but that said, I'm going to work it out fully. We have 9 times 8, which is 72, over 8 times 1, which is 8. Well, you should realize that 72 divided by 8 is simply 9. All right, so the answer to 8 is 9. All right, so let's go ahead and multiply 2 and 1/5 by 1 and 1/10. So far, I've only talked about multiplying and dividing fractions, and these are mixed numbers. So the first thing you're going to have to do is convert these mixed numbers to an improper fraction. That's actually pretty easy to do. Let's convert 2 and 1/5 to an improper fraction. We know its denominator of 5 is going to stay the same. To find the numerator, we're going to do 2 times 5, which is 10, plus 1, which is 11. All right, let's do the same thing for a 1 and 1/10. We know its denominator is going to stay the same. To find its numerator, we do 1 times 10, which is 10, plus 1, which is 11. Then we're multiplying two improper fractions, which means we just multiply straight across. This becomes 11 times 11 over 5 times 10. 11 times 11. You should know what that is, but that said, if you don't, you can always multiply it off to the side. 1 times 1 is 1. 1 times 1 is 1. Before you start multiplication with that one, you have to bring in a zero placeholder. 1 times 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus nothing is 1. So this becomes 121 over 5 times 10, which is 50. Let's go ahead and rewrite this improper fraction as a mixed number now. We have 121 divided by 50. All right, we start by asking ourselves, how many times does 50 go into 1? It doesn't. How many times does 50 go into 12? It doesn't. How many times does 50 go into 121 without going over? Well, 50 times 3 would be 150, which is too big. So this is going to be 2 times. 50 times 2 is 100. 121 minus 100 is simply 21. We have enough to rewrite this as a mixed number. We know this 2 is going to be our whole number. This 21 is going to be our numerator, and this 50 is going to be our denominator. All right, so that is that one. So if you can multiply mixed numbers, then there's no reason as to why you can't divide them. And for number 10, you can see that we have 4 and 1/3 divided by 2. Again, we've talked about dividing fractions in this video, not mixed numbers. So the first thing we have to do in this case is express both 4 and 1/3 as well as 2 as an improper fraction. And that's pretty easy to do. Let's write 4 and 1/3 as an improper fraction. We know our denominator is going to be 3. To find the numerator, we're going to do 4 times 3, which is 12, plus 1, which is 13. Uh, Again, to write whole numbers as fractions, you simply place them over 1. So 2 written as a fraction is the same thing as 2 over 1. Now we're dividing two improper fractions. When you divide two fractions, you follow the algorithm keep, change, flip. We're going to keep this first fraction the same, so we're going to keep 13 over 3 as is. We're going to change from division to multiplication. Then we're going to flip this second fraction, so instead of being 2 over 1, it's going to be 1 over 2. When you multiply two fractions, you just multiply straight across. So this becomes 13 times 1 over 3 times 2. 13 over 1 is 13. 13 times 1 is 13. 2 times 3 is 6. Let's go ahead and express this as a mixed number now that we know how to do that. Again, we're going to read this as 13 divided by 6. We ask ourselves, how many times does 6 go into 13 without going over? It's going to be 2 times, and you should know that 6 times 2 is 12. 13 minus 12 is 1. We have enough to write our mixed number now. This 2 is going to be our whole number. This remainder of 1 is going to be our numerator, and this 6 is going to be our denominator. All right, so 4 and 1/3 divided by 2 is 2 and 1/6. All right, let's talk about the final topic in this video. Notably, let's talk about how to convert fractions to decimals. And of course, you can always convert a decimal to a percent fairly easily. That said, I want to point this out. Most people eventually memorize the common conversions. For instance, most people know that 1/2 is the same thing as 0.5, which is the same thing as 50%. Likewise, most people know that 1/4 is 0.25, which is the same thing as 25%. That said, if you don't like memorizing things, you can always use this method to make the conversions very quickly. So for number one, let's convert 2/5 to be a decimal. And as I've alluded to in this video already, we can read fractions like long division. This as a fraction reads 2 over 5, but as long division, we would read this as 2 divided by 5. And by performing this long division here, we can actually convert this fraction of 2/5 to be a decimal. And let's work on doing that. Uh, let's perform this long division, and we start by asking ourselves, how many times does 5 go into 2? It doesn't. So if it's helpful, you can put a 0 here. And the question is this: how are we going to proceed? Well, we can express 2 as a decimal by placing a decimal here, and we can put as many 0 placeholders after that decimal as we want. Since we have a decimal down here, we can bring it up into our answer. And now we disregard that decimal down here and say, how many times does 5 go into 20 without going over? Well, you should know that 5 times 4, of course, is 20. 20 minus 20 is 0. Since we hit this 0, we know we're done. And the decimal equivalent of 2/5 is 0.4. All right, so that is that one. In other words, by performing long division, you'll know what the decimal equivalent of a fraction is. So let's go ahead and take a look at number 2 now. We have the fraction 15 over 20. We want to write it as a decimal. Before we get started, I want to point this out. 15 and 20 have a common factor of 5. So in other words, we can reduce this fraction before we even get started. 15 divided by 5 is 3. 20 divided by 5 is 4. So this is the same thing as 3 over 4. That's one you should know. You should know that 3 over 4 is 0.75. That said, if you did not know that, let's read this as long division. We read this as 3 divided by 4. And by performing this long division, we'll be able to make that conversion accordingly. We start by asking ourselves, how many times does 4 go into 3 without going over? It doesn't. So we put a 0 above the 3. Now, in order to proceed, we have to put a decimal here, and we can tack on a couple of 0 placeholders. Again, 3.00000 is the same thing as 3. All right. Now we continue by asking ourselves, how many times does 4 go into 30? And again, once we add that decimal here, we have to bring it up into our answer there. How many times does 4 go into 30 without going over? You should know that that's going to be 7 times, since 4 times 7 is 28. 30 minus 28 is 2. Now we drop down this 0. How many times does 4 go into 20 without going over? That's going to be 5 times. 4 times 5 is 20. 20 minus 20 is 0. Since we have a remainder of 0, we know we're done doing this long division. So this is 0.75. All right, so that is that one. All right, so now let's convert 1 and 3/5 to be in decimal form. And this one's going to be easy if you break it apart. Again, we have 1 plus 3/5. So in reality, the only thing I have to convert to a decimal is 3/5. And in order to do that, we're going to read this as 3 divided by 5. And of course, we start by asking ourselves, how many times does 5 go into 3? It doesn't, so you can put a 0 there. And again, in order to proceed, we're going to have to add a decimal and a couple of 0 placeholders. Again, 3.00000 is the same thing as 3. Since we added that decimal, let's bring it up into our answer. Now we move on and ask ourselves, how many times does 5 go into 30? 5 times 6 is 30. So we know 30 minus 30 is 0. Since we have a remainder of 0, we know we're done. 3/5 is the decimal equivalent of 0.6. So this becomes 1.6. All right, so that is that one. And if you needed to see it, you would do 1 plus 3/5 is the same thing as 0.6. 1 plus zero point 0.6 is 1.6. All right, so that is that one. Let's go ahead and convert 30 over 100 to a decimal. And again, you should realize that both 30 and 100 have a common factor of 10. So we can reduce this fraction before we get started. 30 divided by 10 is 3. 100 divided by 10 is 10. All right, you should know how to convert this one without having to do any math whatsoever. That said, let's go ahead and do this one the long way. Um, Again, we're going to read this as long division. So we're going to read this as 3 divided by 10. And we start by asking ourselves, how many times does 10 go into 3 without going over? It doesn't, so we add a 0 there. In order to keep doing our long division, we're going to have to add a decimal and a couple of 0 placeholders. Once we add that decimal, we bring it up into our answer. How many times does 10 go into 30 now? We know 10 times 3 is 30, and 30 minus 30 is 0. Since we have a remainder of 0, we know we're done. So the answer to this one is simply 0.3. All right, let's do one more. Again, we want to write 1 over 9 as a decimal. So we're going to treat this as long division. More specifically, we're going to read this as 1 divided by 9. All right, so let's perform this long division. We start by asking ourselves, how many times does 9 go into 1? It doesn't, so we put a 0 there, and we add a decimal there, and we're going to have to add a couple of 0 placeholders. Now we move on and ask ourselves this. Well, first we have to add our decimal into our answer. Now we ask ourselves this. How many times does 9 go into 10 without going over? That's going to be 1 time. 1 times 9 is 9. 10 minus 9 is 1. Drop down our 0 there. How many times does 9 go into 10 without going over? That's going to be 1 time. 9 times 1 is 9. 10 minus 9 is 1. Let's drop down our 0 there. How many times does 9 go into 10 without going over? That's 1 time. 1 times 9 is 9. And you should see that this is going to repeat over and over again. So the decimal equivalent of 1/9 is 0.11, and that 0.11 repeats infinitely. All right, so that is that one. All right, so that is my complete review of fractions. I hope you found it helpful, especially since I included all these topics in one video rather than spacing them out across 5 or 6 videos. As always, you're more than welcome to leave feedback in the comment section below. And if you want to help my channel out, please consider doing two things. You can, one, subscribe to my channel if you like my content, and two, if you find my videos helpful, you're more than welcome to share links to them on social media, including on Facebook and Twitter. And on that note, I'm going to go ahead and cut you loose.
こんにちは。